A warm welcome to all the students for today's lecture. In this lecture, we are going to design a PDA given a context-free grammar. In all our previous lectures, languages were given to us. The language was either context-free language or regular language. Language was given to us and we were asked to design or construct a push-down automata, maybe NPDA, maybe DPDA for the given language. Now here we are given a context-free grammars with the set of productions, and for that context-free grammar with the set of production you have to design a corresponding PDA. Now for such method there are two types of derivations. You have something called as top-down derivation, you have something called as bottom-up derivation, out of which today we are going to see this first method called as top-down derivation. So a PDA that simulates top-down derivation, okay, here there is a small procedure that we need to use. Okay, very first thing what you need to do, first of all you will be having a string, which a valid string in the given grammar, okay, input string. You will be also having a stack which is initially empty. Now initially the string is unread, no element of the string, no symbol of the string is initially read. Okay, similarly the stack initially is empty and you will be in the initial state. Now with this setup, let us see the procedure. First you need to initialize the input pointer to the beginning of the string. Okay, next, now whenever we deal with context-free grammars, context-free grammar will always have something called as start production, and that start production will have something called as start symbol. So after initializing the input pointer to the beginning of the input string, second step, you have to push the start symbol of the grammar onto the stack. Okay, now third thing, now once you push elements onto the stack, earlier stack was empty, now stack will have some elements. So in step 3 we have to analyze the topmost element of the stack. Okay, and there are two cases. Now if it is a variable, that means if the topmost element of the stack is a variable or a non-terminal, let's say A, then we need to search for the production with its left hand side as A. Okay, or in general, suppose A is a non-terminal present as a topmost element on the stack, then out of all the productions, find out where is that A production. Okay, now then A which is there on top of the stack is replaced with A production's right hand side. Okay, you first find A production whether it is there. If found, then that A which is there as the topmost element of the stack, that A you have to replace it with the right hand side of that A production, of course in the reverse order. Okay, now if the top of the stack is a terminal, okay, if the topmost element of the stack is a terminal, then you start reading the input string from the very first element. Okay, and then you compare the current input symbol with the topmost element of the stack which is a terminal. If both are same, that means there is a match between the topmost element of the stack which is a terminal and the current input symbol which is red which is also a terminal. If they match, then they are cancelled out. That means the topmost element of the stack is popped out from the stack and the input pointer moves to the next symbol. Okay, and then you go to step A. Again you check who is there on top of the stack. If topmost element of the stack is a non-terminal, then suppose let me call that non-terminal as capital X. Then you find out whether there is X production. Once X production is found, you replace this X which is there as a topmost element of the stack with the right hand side of X production. Okay, so with this then again you check, okay, whatever is the content of the stack, within that suppose the topmost element is now a terminal, not a non-terminal, then what to do, you start reading the current input symbol and compare it with the topmost element of the stack. If current input symbol and the topmost element of the stack which is a terminal, if they are same, cancel them out and so on. So this procedure A or B, this is repeatedly followed as long as the stack does not turn out to be empty. Okay, finally after repeating 3A, 3B, that is this and this step, once the stack is empty, you stop. Okay, so in this process you will also basically this procedure which I have shown you, this is basically how the top-down PDA, I call it as top-down PDA, how it functions. Okay, so for example, they might give you this kind of question: design a top-down PDA for the context-free grammar G whose productions are given as follows. Okay, and suppose the productions given are S gives S plus T, S gives T, T gives T into A, and T gives A. Okay, what I showed you here, this is the way how PDA, once top-down PDA is designed, how that PDA will validate a string, how it will process the string and find out whether the string is valid or invalid. For that, this is the procedure. Okay, so this is a procedure to validate a given string, whether the string is accepted or not. Now, there is another some set of steps, okay, that we are going to see to design the PDA at first. Okay, the procedure that is there here, this once the PDA is there already, this procedure you will be using, PDA will be using this procedure to validate whether the given string is accepted or rejected. But then how to construct PDA? To construct PDA itself, there is one general procedure. Okay, the following steps are used in general to design any top-down PDA. Okay, now remember, no matter what grammar is given to you, okay, your PDA that you are going to generate, that will have only 3 states, always Q0, Q1, Q2, and the set of steps that I have written here, you are going to follow exactly the same set of steps. No matter what productions are given and what grammar is given, the PDA will, the structure of the PDA will appear almost same. What will change is the productions. Okay, you will come to know this. So let me design a PDA simultaneously as we execute each and every step. Okay, so we start. The derivation begins from the initial state Q0 and the start symbol of the grammar is pushed onto the stack. Okay, so which means let Q0 be the initial state. Okay, let Q0 be the initial state. Now, initially what will happen? Initially, your input string that is given to you will not be read. It is unread. Okay, nothing is read as input. So when nothing is read as input, what is read? Null is read initially. Okay, then at that time your stack will be also empty. Okay, stack will be also empty. Okay, now so in Q0 state, when nothing is read as input yet and stack is also empty, so this is initial condition. That time what I am going to do, the start symbol I am going to push onto the stack. Now why S? Because in the given grammar that the productions are S gives S plus T, S gives T, T gives T into A, T gives A. So here we can see that S is the start symbol. Okay, so in step 1, what you need to do, you need to design state Q0, initial state. It is a state wherein input string is not yet read, nothing is read from the input string, that means null is read, and the stack is also empty, so Z0 is the topmost element. So in state Q0, when nothing is read as input yet, stack is also empty, what you are going to do, you are going to push the start symbol onto the stack SZ0, okay, and you are going to move to state Q1. So this finishes with step 1. Okay, remember, no matter what grammar is given to you for exam and what production it has, this first step will be always the same. Fine, so this is step 1. Now another question before I actually write the productions, remember, okay, unless and until the topmost element of the stack is not a terminal, unless and until the topmost element of the stack is not a terminal, your PDA is not going to read the input string. Okay, so PDA will start reading the input string, the current input symbol, only if the topmost element of the stack is a terminal. If the topmost element of the stack is a non-terminal, or if the stack is empty, the PDA is not going to read the input string. Okay, so input pointer won't be reading the inputs. Okay, remember this. Now in step 2, when PDA is in state Q1, if the topmost element in the stack is a non-terminal, okay, then the non-terminal is replaced by appropriate right hand side of that production. Clear? If the topmost element is a terminal, then it is compared with the current input symbol and popped off when both are same. Okay, now let us understand what we are trying to do. These are the set of productions that are given to us. I will simply copy just for our reference. Okay, and I will use it here. So these are the set of productions that are given to us. Okay, so in step 2 what we do, when PDA is in state Q1, if the topmost element of the stack is a non-terminal, then the non-terminal is replaced by the right hand side of the production. And if topmost element is a terminal, then it is compared with the current input symbol, and if they are same, that means current input symbol and the topmost element is same, then they are popped off. Okay, now the very first production that is given to us is S gives S plus T. Now you tell me, currently in state Q1, which symbol is on top of the stack? See, you have just pushed start symbol on top of a stack. So what is there on top of a stack? The start symbol. What is start symbol? It's a non-terminal. So whenever there is a non-terminal appearing on the as the topmost element, what you need to do? You need to seek for S production. Now there are two S productions here. Correct? This is one and this is the second S production. And the S which is there on top of a stack, you need to replace it with the right hand side of the production. Okay, so I will first write the productions. Okay, so for the first production, now since on top of the stack here, it's a non-terminal, is the input string going to be read? No. Okay, so when nothing is read as input string yet, and suppose S is on top of the stack, then since S is a non-terminal which is there on top of a stack, the non-terminal S will be replaced with the right hand side. Okay, S will be replaced with S plus T. So what will be pushed onto the stack in place of S? The string that will be pushed onto the stack in place of S will be S plus T. Now of course in reverse order it will be pushed, but the string itself is S plus T. While pushing it will look like T plus S, but what you are pushing, it is the original string S plus T, right? So for the first production, this is the transition. Very simple. Also, okay, also see S, we are replacing it with S plus T, but S also has another term in the production. S can be also replaced with T, so I have to write that also. So when nothing is read as input yet, and S is on top of the stack, a non-terminal on top of stack, S can be also replaced with T. So this is how both the productions have been taken care of. Next, now it can so happen that in this particular calculation, as the PDA goes on operating, it can so happen that another non-terminal may appear as the topmost element of the stack. Now what is the other non-terminal? There is another non-terminal in the grammar, that is T. Okay, so again see, when non-terminal is there as topmost element, you are not reading anything from the input string. So I will just write for the next production, for this production I will write when nothing is read as input. Why? Because non-terminal T is on top of a stack. Then what we will do? We will search for T production. This is T production, and we will replace T with the right hand side of T, that is T into A. Now T into A will be inserted into the stack in the reverse order, so it will be inserted as A into T. Okay, but what is inserted is the original string, that is T into A, right? So if T, a non-terminal T, appears as the topmost element of the stack, right, that time you are also not going to read the input string, and T will be replaced with the right hand side of T. What is right hand side of T? It is a string T into A. So T into A will be pushed inside. Now while pushing, it will be reversed and pushed. So don't have to write a reverse order here. Write the original string only here. Okay. So this takes care of this production. Now for the final production, okay, T can be replaced with T into A, but T also can be replaced with a single A. So that possibility is also there. So another production. So when nothing is read as input, and suppose T is on top of a stack, one thing is T can be replaced with T into A, but T can be also replaced with A. So I can also write T can be replaced with A. So these are 4 transitions for all these 4 productions. Fine. So in step 2, what we have done is, if the topmost element of the stack is a non-terminal, then the non-terminal which is on topmost on the top of the stack is replaced by appropriate right hand side of that production, and that's why S was replaced with either S plus T or T. So we got these two transitions, and T was replaced with either T into A or A. So we got these two productions. Okay, so this finishes off with the first thing, that if the topmost element is a non-terminal, then what? Now in step 2, if the topmost element of the stack is a terminal, then what you do? If the topmost element of the stack is a terminal, then you start reading the input string. And if the current input symbol is same as the topmost element of the stack, then you cancel them out. So I need to represent that also. Now you see, what are the terminals present in this grammar? There is only one terminal, that is A? No, there are 3 in fact terminals. Plus is also a terminal, into is also a terminal, A is also a terminal. Okay, so now let's assume in this process, in this process of calculation, suppose A happens to be the topmost element of the stack. Okay, so it's a terminal, no? So you need to read the input string, and in the input string, suppose A is read as current input symbol, and now the topmost element of the stack is also A, suppose, then cancellation will happen, right? So in this process, suppose the topmost elements of the stack is a terminal. That time you check the input symbol, and suppose the input symbol is also A. See, all this time I had not been reading the input symbol. Why? Because on the top of the stack there was non-terminal. But now suppose in this process, suppose the stack top element happens to be a terminal. That time I read the input string, and input string is also same, suppose, then we cancel them and we pop the element out. Okay, so this is regarding A. There is another terminal also, into is also a terminal. So suppose now assume that if into is the topmost element of the stack, that time also you will be reading the input string, and suppose input string is also into, then you pop it out. Okay, I don't have place to write here. I will be just writing, I'll be writing the next thing here only, because I don't have place here. Here I'll write. Okay, so into is the next terminal and plus is the third terminal. In the similar lines, you can say if plus is the topmost element of the stack and plus is the input symbol, then the cancellation will happen. So for state Q1, the productions are 1, 2, 3, 4. These 4 productions the transitions are, these 4 productions are for the 4 transitions. And 1, 2, 3, these 3 transitions are for the 3 terminals. So no matter what grammar is given to you in exam, no matter what production the grammar will have, you will always write it like this. Q1 state, you are going to represent all the productions with respect to their transitions, and the transitions for the terminal strings. Okay, so this is step number 2. Step number 3, when the stack is empty, a null transition is provided from state Q1 to Q2, that is initial state, that's the final state. So I said the PDA will have 3 states. Third state Q3 will be always, Q2 it is, not Q3. Q2 will be always the final state. Okay, third state Q2 will be always the final state. Right? Now in step 3, what they are telling us, when the stack is empty, so in this process finally, suppose the stack turns out to be empty. If the stack turns out to be empty, then a null transition is provided from state Q1 to Q2. Null transition means when there is nothing remaining to be read, that's a null transition. Okay, so finally in state Q1, suppose there is nothing remaining to be read in the input string. I'll just tell you the meaning of this. It is nothing but when you are in Q1 state, after doing all these transitions, when there is nothing remaining to be read in the input string is exhausted, and at that time stack also turns out to be empty, then what you do? You perform no change operation and you go to state Q2. What you see in front of you is the push down automata. Okay, it's a top down PDA for the given grammar. It's very simple. Okay, so for exam, any grammar is given to you, any production it has, the PDA will be exactly looking like this. What will change is based on the productions, only these transitions will change, but other than that everything will appear same. It's very easy. Okay, so always remember these 3 steps you have to follow in general to design any top down PDA. Now after doing this, they have asked you to validate the given string. Now to validate this given string, I have to use this procedure, which I am going to explain you next. Okay, so just to show you the validation, okay, validating the string a plus a into a, I am showing it with the help of a table. Okay, so this is the symbol red, current symbol which is red, or so far which are the input symbols which are red. Okay, will be appearing here. The unread input, in the input, whichever symbols are not yet read, remaining to be read, they will be appearing here. This is the current state, and this is the content of the stack at any moment. Okay, so initially nothing is read. Fine, no symbol is read. So they have asked you to validate the string a plus a into a, so that whole string is unread initially. You are in the Q0 state, you are in this Q0 state, and the stack is also initially empty, right? So as the part of the first thing, what you do, okay, this procedure tells you have to initialize the input pointer to the beginning of the string. So we have to initialize, so input pointer will be pointing to the beginning of the string here. This is the input pointer, right? And in the second step, what we are going to do in the second step, push the start symbol of the grammar onto the stack. Okay, now in this grammar that is given to us, as you know, S is the start symbol. So what we do, so initialize the input pointer, stack is empty. In the next step, see again nothing is read. What we are doing, we are simply pushing the start symbol on the stack. So earlier stack was empty, now the start symbol has been placed onto the stack. And by doing that, from state Q0, by pushing the start symbol, I am going to state Q1. So you see, from state Q0, I have moved to Q1 state by simply pushing the start symbol on top of stack. Nothing is read in the input. Input string is not yet read. When you are going to read the input string, only when the topmost element of the stack happens to be at terminal, only then you are going to read the input string. Otherwise, you don't read at all. Fine. So this is step number 2. Then, now step number 3 here for validating, it says examine the topmost element of the stack. Now you need to examine who is there on top of the stack. Now if it is a non-terminal as the top of the stack, say A, then you need to check whether there is a production in the set of productions. Then go to that A production and replace that A which is there on the stack with the right hand side of A production, of course in the reverse order. So what is there on top of the stack? It's a non-terminal which is there on the top of the stack. Okay, so then you go to S productions. These are the set of productions. S is on top of the stack. So we have 2 S productions. One is S gives S plus T, second is S gives T. So what I do, you can use any one, either this one or this one. I use the first one. So what I will do, I will replace the topmost element S, capital S, with the right hand side of S. Now what I am going to replace it with is S plus T, but while inserting I will be inserting it in the reverse order. So T will go first, then plus, then S. Okay, so as you can see, S is being replaced with S plus T. Okay, the string S plus T is inserted in reverse order, that's why T has gone first, then plus, and then S. So while reading, it still is read as S plus T only, that's why we reverse and insert. Remember this. Okay, so after doing this, so we have executed step 3a. Now after step 3a, okay, step 3b is to be executed when the topmost element of the stack is a terminal. But after doing this particular procedure, what is the next topmost element on the stack? It is still a non-terminal S. right? It is still a non-terminal S. So again you see here you have to execute either A or B, and after that go to again step A. So we have executed this part. B was not required because topmost element of the stack was not a terminal. So again we go to step A. We have come here. Now again the topmost element of the stack happens to be a terminal here, a non-terminal here. So I will now replace the S. Earlier I replaced S with S plus T. Now I will replace S with T. So this S I have replaced it with T. Correct? T. So far see, not a single symbol is read. So an unread input is the whole original string. So when you are going to read the input, only when the topmost element of the stack happens to be a terminal. Till then you are not going to read the input string. This thing will go on processing. Okay. Now again see, at this stage again you examine who is the topmost element of the stack. It's a non-terminal. So again you go to 3A. Okay, step 3A. If the topmost element is a non-terminal, then again go for A production and replace the right hand side in reverse order. Okay, so see here, it is T, right? So there are two T productions. One is T gives T into A, T gives A. Now you could have replaced it with this one or this one. Okay, any one. I will replace it with this one. Okay, so what I will do, I will replace this T with the right hand side of T production. That is, I will replace it with this one. You can do it, you can replace it with this one also, no problem. So I am replacing T with the right hand side, that is small a. So the T which is there here, I am replacing it with small a. So far nothing is read. But now what is happening? Who is there on top of the stack? Top of the stack is a now terminal symbol. So go to step A again. Is the topmost element of the stack is now non-terminal? No. So I cannot execute A. So then I go to step B, 3B. If topmost element of the stack is a terminal, then what to do? Then it is compared with the current input symbol. So far input symbol was not read. So now you will be reading the current input symbol and compare that current input symbol with the topmost element of the stack. And if both are same, then popping will happen and the pointer will move to the next input symbol. Very simple. Right? So since the topmost element of the stack is a terminal, now I will be reading the first input symbol, that is A. So that's why I am writing A here. What is this column? It is the symbol that is being read, or symbols that are so far read, and this is so far unread, right? So the first A here, the first A I am going to read. So then after reading this A, what remains? Plus A into A. So this string will remain. This is so far unread, and what is read is A. Now the input symbol, the current input symbol A here, the first input symbol is checked, it's compared with the topmost element. Are they same? Yes. This A and this A is same. So what will happen? Two things will happen. The pointer now moves, the input pointer now moves to the next input symbol. That's why plus is being written here. Okay. A is already read. So the current input symbol now moves one place to the right to the next input symbol, and the topmost element of the stack, that is A, is it's compared and it is cancelled with this A. Okay, so A is popped out of the stack. Correct? So since the topmost element of the stack is a terminal, what we have done? We have cancelled this with the current input symbol A. So since A is already read, the pointer has moved to the next input symbol. So unread input symbol, unread input string is this, and current input symbol that is being read now is this plus. Whereas this A which was on top of the stack is already being popped out. Next you again examine who is there on top of the stack. It is a terminal. So since it's a terminal, you read the current input symbol. So next, which input symbol is read after A? Plus is read. Now is plus matching with this plus topmost element? Yes. So what will happen now? This plus will be removed from the stack. So see, plus is removed from the stack, and this plus is added to the already read input string, and unread input string that is remaining to be read will be A into A. After scanning this plus, what remains is A into A, and the pointer is now pointing at the first A over here, whereas the current content of the stack is only capital T. Plus is removed by comparing this with this plus. So plus is already read. What remains to be read is A into A. Your current input pointer is pointing to this A, and stack currently contains T only. Okay. Fine. Now again you check who is there on top of the stack. It is T. So that means it's a non-terminal. So non-terminal can be either replaced with the right hand side of this T production or right hand side of this T production. Now here you have to be slightly brainy. See, your aim is what? Finally the input string, entire input string after reading, it will be cancelled with the stack. So finally the stack should be empty and the string also should be completely read, right? Now check what is remaining in your in the unread input string. What is remaining? Okay, see here. In the unread input string, what is remaining is A into A. So there is a multiplication sign and there are two operands. So this has to be cancelled. Correct. So if this T, if I just replace it with small a, there is no way I will be able to cancel that into. Correct. So instead of replacing it, the T with this one, I will now replace T with T into A. Why? So that this into will come into picture. Into you will be able to cancel it with the input string. Otherwise into will remain and you will not be able to cancel up. So the topmost element T on top of the stack will be replaced now with T into A. But while inserting, it will be inserted in the reversed order, that is A into T. Okay, I am following this. I am still in Q1 state. Please see, all this processing is happening in Q1 state only. Okay, so T I will be now replacing it with T into A. So the topmost element T, I am now replacing it with T into A. But how I have reversed, how I have replaced, I have inserted the element in the reverse order. So what went first was A, then into, then T. I wanted to push T into A, but what I have pushed inside is the reversed, that is A into T. So it appears like this. We are still in Q1 state. Up till A and plus, it is already read. What is unread is this part. You are in Q1. Now again you check who is there on top of the stack. It's a non-terminal. So since it's a non-terminal, you try to replace this with the right hand side of T. You can replace it with again T into A or A. But now if I replace T with T into A, don't you think I will be introducing another into symbol? In the given input string, there is only one input symbol, into symbol, multiplication symbol. But if I again replace T with T into A, don't you think in the stack you will get another into symbol which will be difficult to cancel? So you don't replace T with T into A, rather you replace T with single A. Fine. So where are we? We were supposed to replace this T. So what we'll do? We'll replace T with a single A. Now again, what is there on top of a stack? A terminal is there on top of a stack. And what is the current input symbol? Small a is the current input symbol. Are they matching? Yes. So two things will happen. First, A will be cancelled out with this A. That means A will be popped out. And since this A is already read, A will be added to the already read input, and the pointer will move to the next input, that is into. So this is the current input pointer. The current input pointer is now pointing to this symbol, that is into. So this is unread so far and this is read so far. You are still in Q1 state. After A is removed from the stack, what is revealed? Multiplication sign. Into is revealed. Now is it a non-terminal or terminal? It's a terminal. So again, since this is a terminal, you check the topmost element, this is topmost element of the stack. Since it's a terminal, you check the current input symbol, that is into. Are they same? Yes. So two things will happen. One, this into and this into will be cancelled out. That means into will be popped out of the stack. Second, since this into is already read, it will be added to this list and pointer will move to the next input symbol. So what is unread? Only this will be remaining to be read. The rest, everything is read. And after removing this into from the stack will look like this. Correct? Next, again see who is the topmost element of the stack. It's a terminal again. So you check the current input symbol. Is it same? A and A. Yes. So two things will happen. One, A will be popped out. That means A will be cancelled out with this A. Okay. And since this A is already considered, it will be added to this list. And what is remaining to be unread will be null. That means there is nothing else remaining to be read. After removing this A, stack also will turn out to be empty. Okay, now please note, all elements have been cancelled out and there is nothing remaining to be read, and stack is also empty. You are in state Q1. So you see, according to the PDA that we designed, when we are in state Q1, when nothing is remaining to be read and stack also has turned out to be empty, you do nothing, you perform no operation, and you simply go to state Q2. So that's why you see in the last step, nothing more is left to be read. Okay, null and null. From Q1 you will simply move to state Q2. Okay, you will simply move to the state Q2, and I think I have made a mistake here. Okay, I will rectify it, and stack is also empty. Okay, so from Q1 you are simply moving to Q2, stack is empty and there is nothing remaining to be read. What is Q2? Q2 is a final state. Fine. So this is how you have to validate the given string. This is how you have to design a top-down PDA. For any PDA that you draw, no matter it is NPDA, no matter it is DPDA, or the problem that I have solved, top-down PDA, bottom-up PDA, whenever there is a PDA that you are drawing, okay, after drawing the PDA, it is always good that you design a transition table. Now, in case of PDA, the transition table will have state. Okay, state resembles the current state. Input, what is the input symbol that is currently read? Top of the stack, which symbol is currently on top of the stack, and the moves that the PDA makes. Okay, so moves, top of the stack, input and state, these are the 4 parameters that you are going to consider, and each transition which is there in this particular PDA you are going to write in a transition table. For example, let us consider the first transition. Okay, let us consider the first transition, that is this. So currently when you are in state Q0, the input symbol that is read is null, stack is also empty initially. Okay, what happens? PDA moves to which state? PDA moves to state Q1 by doing what? What is the operation that is performed on the stack? Okay, start symbol S is pushed onto the stack. So the string SZ0 is the one which is pushed onto the stack. Okay, so this is for the transition that connects Q0 and Q1 for this transition. Now let us see for this transition. Okay, let us see the tuple for this transition. So current state is Q1, the input read is null, start the top of the stack is S, that is the start symbol is there on top of the stack. Okay, where do you go after performing the operation? You remain in the same state Q1, and what is the operation that is performed on the stack? You are pushing the string S plus T onto the stack. So what you are pushing in onto the stack is S plus T. So when you are writing the moves, it will have 2 parameters. The first parameter will tell you what is the state where you reach, where the PDA reaches after the transition, and the second parameter here tells what is the string that has been pushed onto the stack. May it be a push operation, may it be a pop operation, or may it be a no change operation. Okay, so then we are going to see the next one, this transition. So basically in PDA here, the transition table that we are drawing, it just tells you, it is just a textual representation of whatever visual stuff that you have created. Okay, so now for the next transition, again the current state is Q1 only. When null is read and S is on top of the stack, okay, you remain in Q1, and what is the string that is pushed? T, right? Then for the next transition, that is this one, okay, again the state is Q1, the current input symbol is null, okay, top of the stack is T, you remain in the same state Q1, and what is the string that is pushed? T into A, right? Then the next transition, again you are in state Q1, null is read as input, T is the top of the stack, and you remain in the same state after the transition, and what is pushed onto the stack is A. Now again the input, I am talking about the next transition, input symbol is Q1, the current state is Q1, I am sorry, the input symbol is A, top of the stack is also A. By doing this transition you remain in Q1, but then what do you push inside? Basically it's a pop operation. What you're pushing inside is null, right? Similarly, for this operation, you are in Q1. When plus is encountered as the input symbol, plus is on top of the stack. You remain in the same state by doing what operation on the stack? Popping. So it's again pushing null. And for the last one, for into, okay, you again remain in the same state, and since you pop out, this is the operation that is performed. And finally, okay, this transition, last transition that we are going to see. Now you are in state Q1. When do you go from Q1 to Q2? You are in state Q1 when null is read as input, stack top is Z0. Okay, you go to for the final state Q2, and what operation is performed on the stack? No change operation, so Z0 remains on top of the stack. So remember students, transition table is nothing but it is just textual representation of the same transitions. Now some students will have a wrong notion. Transition table does not tell you step by step how you have achieved the output. No. Okay, that means if you trace this transition table step by step, you will not be able to solve a problem. What is basically a transition table? Whatever transitions which are there in the PDA diagram, we are just writing them in this textual form. Okay, in any order actually. I have taken this order. So although because of shortage of time in the previous videos, wherever I had designed NPDAs, DPDAs, okay, or even in the last problem, because of shortage of time, I did not give stress on transition table. But now I will tell you, whenever for exam, when you are going to draw PDA, okay, if you have time, it is always better that you also draw a transition table of that PDA. Thank you.